Okay, hi there. Today we're going to be looking at Chapter 7-1 for Algebra 2 on exploring exponential models. So there's a couple of different exponential models I'd like to show you. The first and most basic kind is y equals a times b to the x. We use this for a lot of different kinds of problems, and if a is greater than 0 and b is greater than 1, then it's exponential growth. If a is greater than 0 and b is between 0 and 1, then it's going to be exponential decay. The y-intercept is 0a, so a determines the y-intercept. And I wrote a couple examples there right here. You can see that since the 3 here is greater than 1, you would know that it's exponential growth. And over here you can see that the 1/2 is between 0 and 1, which means it's called exponential decay. So it'll be getting less and less as you go along with exponential decay. Exponential growth, as the words would imply, gets bigger and bigger. The initial amount's a, which comes in the front of the exponent, okay? Not the base, but in front of the exponent with the multiplication there. Now, this one's a little different. This one has to do with periods of time. This is similar. This one usually is used with percentages. So if I said y is the total amount, a is the initial amount, rate of growth would be if r is greater than 0, or decay if it's less than 0. So used mainly with percent problems. All right, so next, I'm just going to jump right in. The first one, you invest $1,000 in a savings account that pays 5% annual interest. How much money will be in the account after 6 years? Okay, so this problem, it's got percent in it. Now it's important to remember that 5% is 0.05. That's important. That's actually going to be r. It's going to be 0.05. T is the amount of time, which will be 6 years. A is the initial amount, which is the amount that you put in the bank to begin with, which would be $1,000. And Y will be the total amount. So if I plug those numbers into my equation, 1,000 times 1 plus 0.05 to the t, and t is 6, and punch that into my calculator, I will get an answer. So the way you want to do this is you want to add the 1 and the 0.05 first, and then take that to the 6th power. Make sure you do the exponents before you do the multiplication. If you did that correctly, you should get 1.34, 0.00956, etc., etc. And then you multiply those two things together, and you get an answer of $1,340.09. Or 10 cents if we round off. Okay, that's the answer. Next one. Your credit card charges you 1.25% interest per month. Boy, it's low. You owe $4,000. How much will you owe after 1 year? So for this one, you're going to want to take the same equation, the y equals a times 1 plus r to the t power. R is going to be the rate. So remember, 1.25, to go from decimal to percent, you must divide by 100, which makes it 0.0125. This is the percent, so 0.0125. You can also move the decimal point 2 to the left. Let's see, A is the initial amount. I should make that a lowercase a so I'm consistent, which is $4,000. And T is 1 for 1 year. So if I plug all that in, I get 4,000 times 1 plus 0.0125 to the first power. And since it's to the first power, it really stays the same, which means if you do this out, you should get $4,100. Okay, and there's that problem. Number 3, you try. Why don't you see if you can get this one? So hit pause and then come back after you've done this yourself. Okay, here's the answer that I got. Hopefully that's what you got. Next one. A population of 1,200, doesn't say what the population's of, sometimes it could be animals or whatever, grows 3% for 5 years. What is the population after 5 years? All right, so this one, I'm using that same equation, y equals a times 1 plus r to the t, where in this case y equals 1,200, because that's how many we started with. 3%, reminder 3% equals 0.03. So that's 1 plus 0.03. And the t is amount of time, which is 5 years. Okay, so I plug all that into my equation, and then I go 1.003 to the 5th power, which gives me approximately 1.15927 times 1,200. And then multiply, right? Notice how I did the addition, the parentheses first, then the exponents, and then the multiplication, just like PEMDAS and the order of operations. So if you did this outright, you should have gotten $1,391.13. Oops, it was population, not money. So I don't want to put that. All right, so since it's a population, you might very well want to round off to the nearest person or deer or rabbit or whatever it was there. But I've never seen anybody knock off credit for being too exact. Okay, next one. Population of 60,000 decreases by 20% for 4 years. What is the new population? All right, so this one a little different because it's decreasing. So A is the initial amount, which is 60,000. 20% is 0.20. So that's my rate. Now it's decreasing, so I'm going to throw a negative on there because it's going down 20%. T is the amount of time for 4 years. Okay. Which means if I'm going y equals the initial amount, it's the same equation, a times 1 plus r to the t. So 1 plus negative 0.2 or negative 0.20 to the t is 4 years. All right, so there it is, which makes sense, right? If it's going down 20% per year, then you are left with 80%, which is what you get in the parentheses, which is 0.8, okay? So I got 60,000. And let's see, so if I do that out, you should get y equals, remember to do the exponent first, 24,576 is what I'm getting here. Okay. Next one, number 6. Does this represent exponential growth or decay? Y equals 100 times 0.6 to the x. Well, the only thing that really matters with this question is, the 0.6. Since it's between 0 and 1, this will represent exponential decay. If they ask what's the initial amount would be 100. Okay. All right, next. One of the most important lessons I give every year is this one, and it's on compound interest. Because compound interest is just everywhere, pretty much everywhere that money is involved, this formula comes into play. So this is a formula: A equals P times 1 plus R over N to the NT power, where A is the total amount, very similar to the last formula we used. P is the principal. Principal is the initial amount. Write that on the side. Oops, wrong spot. R is the rate in percent. N is the number of times that the interest is compounded per year. Usually in the real world, it's 12, okay? Usually it's monthly. But in some math problems, they change that around. So if it was annually, that would be once, okay? If it was biannually, that would be twice per year. Quarterly would be 4 times per year, okay? But usually it's monthly, which is once per year. 12 times per year, sorry. So anyway, I wrote those on the side for you. And T is the time in years, okay? All right, so that's the formula, and it's got N is used twice, okay? So you can see it's in the bottom of that fraction, and then it's also in the exponent. The N and the T are connected by multiplication, okay? So here's the first problem. It's this, that you deposit $40,000 in a bank account that pays 2.5% interest annually. If the interest is compounded monthly, how much will you have after 3 years? So I'm going to use that formula, the A equals P times 1 plus R over N to the NT. I'm going to write down what each thing is. So P is the principal, the initial amount, which is $40,000. R is the rate. And now remember, it's rate in decimal, so 2.5% equals 0.025. That's the biggest mistake I see on a regular basis. Kids will plug in the 2.5% and and then they come back with this astronomically huge number. Remember, this is real world kind of stuff. So if you put $40,000 in the bank and you come back and you had made $4 billion, probably made a mistake, all right? You might want to go double check your math. Okay, so these are all the things I need, I think, here. Let me plug them into my formula. A equals 40,000. 1 plus R is 0.025 over N, which is, I forgot to write N is 12 because it's compounded monthly, to the 12 times 3. Okay, so depending on what this number is, you might want to do it out in your calculator ahead of time. If that's going to be, if that was 12 times 18, you might want to punch that in there, so because it's easier to work once you know that number. It's easier to punch it in because you can do that to the exponent in your calculator. So next, I start with what's in the parentheses. I'm doing that first. 0.025 divided by 12. I do that first, which turns out to be like 0.00208 or so, something, to the 36 power. 12 times 3 is 36. And then I'm going to add the 1 and take that to the 36 power, okay? So when I do that, I get 40,000, and this comes out to approximately 1.0778. I usually just leave the number in the calculator after I take it to the 36 power and then multiply it right out times the 40,000, and I get $43,112. Okay? So, not bad. A common kind of question is, I'm going to do it next also, but, if I start out with $40,000 and after 3 years I had $43,112, how much did you make in interest per year? And what you do is you subtract the 40,000, take the 43,112, subtract the initial amount that I put in the bank, and I get $3,112. And that was for 3 years, which means if you divide it by 3, you'll find out how much you made each year, which would be like $1,004 or something. So, not a ton of money, but pretty nice chunk of change, though. $1,000 for doing nothing. That's pretty good. Anyway, that wasn't what the question asked for, but I figured I'd go a little farther. All right. So this is the other one I'm going to do. You owe $8,000 on a credit card that has 11% annual interest that is compounded monthly. How much in interest do you pay in 1 year if the debt stays the same? Okay, so this is more along the lines of what we were just talking about. Same formula, A equals P times 1 plus R over N to the NT. P is the principal, the initial amount of the loan. Interest is a one-way street. Well, no, it's a two-way street. Somebody owes it and somebody pays it. So it's always better to be the person that's getting paid the interest. In this case, you owe the money, so you're paying the interest. Whoever owes the money is paying the interest. So my rate is 11%, which is 0.11. You would divide by 100 or move the decimal point 2. Next, T is 1, and N is how often it's compounded, and it says compounded monthly. Just a quick note, if it doesn't say anything about interest being compounded, this is not the formula you're using. This is strictly for compounded interest, okay? N is 12 in this case. All right, so if I plug all this stuff into my formula, I got 8,000, 1 plus the rate, which is 0.11, which isn't even that much compared to some credit cards, over N, which is 12, to the 12 times 1. All right, next you're punching that into your calculator, all right? So I got the 8,000, but I save that for last. So first I go 0.11 divided by 12, hit equals, and I got 8,000 times 1 plus 0.00916 repeating to the 12th power, then add the 1. So I get 1.0916 repeating to the 12th power. Now I take it to the 12th power. I get 1.1157. I'm just leaving that number in my calculator to be exact as possible, because there's more after that 7. And then multiply it by 8,000, and I get $8,925.75. We round off to the nearest penny when it's a money problem. Okay, so 75 is where you round off, which means if I want to know how much in interest in 1 year we are paying, I subtract the initial amount, which was the $8,000, and I get $925.75 each year. So for that would be per month. You're paying $77 per month just for holding that. I should say per year. A lot of people have a lot of credit card debt. $900 is a lot of money to pay every year for just owing money. It'd be nice not to pay that. $900, I'm sure you could think of something you'd like to do with $900. I know I can. So anyway, that was my last problem for the night. And you guys have a great night. And I'm going to close it out with my extra.